Hello everybody, it's Damon. Crazy Logics most places, Crazy Logics 007 on YouTube. And we're back on this Rockford. You'll have to excuse my fingers there. I've been working on the truck. It's been giving me some problems. Ain't got it all fixed yet, but I'm a little dirty. I wanted to get another video going here, at least doing these strips and stuff. But we'll get the heat sink out of the way here. And actually we're going to move this board out of the way because I talked about the caps and what they looked like if they was popped and all that other stuff, and I knew I had an example somewhere, and so I dug through all the different amps I had and everything else and found one. So give me just a sec, because it's big. Oh, this is a concept amp. Not sure. That's kind of an off-brand. I'm going to use my little microphone here. When I opened this up, it had blown the input filter capacitors, and then I could push in on these, and this was flat, but that was the cap was missing. It wasn't in here, so somebody's peeked in here before or something. It's either that or I haven't found it like floating underneath the board because I haven't had this out. This thing, you can see here, has got a blown power supply bigger than all get outs. These did leak. They sprayed on the cover on the bottom side. I did immediately look and see if any of it had got on the circuit board, the electrolyte, and it didn't look like it, so I was able to wait to work on this. It's way down on the bottom of the list, but like I said, either somebody cut this off or it got hot in here and popped off. But I'm going to see if I can get my, there we go. So let's see. Oh, if I can somehow make it a little less, there, we get rid of some glare. Okay, so see how the top of that cap is actually flat, but here is a regular cap, and you can smash down on that plastic piece and you can tell that it's still flat like this one. Now if we go over here, let's get the glare off. You can see how there's that yellow substance on the top, and those caps are all swollen. So we can get down any lower. They're bulged up. I wonder if I leaned it back a little. Get that shadow off there a little, or get a shadow on there a little bit. Anyway, those have let out their electrolyte, and that's what we were talking about on the caps, and when we were checking the caps, and that's what you're looking for, is these swollen caps. I don't know if I can turn this. Yeah, I kind of can. You can see that they got a swell on the top of them there. So I just wanted to show an example in case you've never seen it before, or that way you at least know what it looked like. So anyway, today we have our Rockford back out, and we are going to work on these MEHSA strips. So now, like I said, I call them MEHSA. It's technically MEHSA, so MEHSA. I don't know. I'm a little bit redneck, and so my pronunciation isn't perfect. So we're going to carefully lift up these bias transistors, and we're going to remove the thermal sensor and get it up out of the way. And we got these 4 to do, so we pay attention to where we're at here. And we're going to add some solder, and we're going to then solder suck these a little, and I'll show you why. I'll get the zoom cam again. I'm going to add solder to all of them. Fresh solder, always a great idea, depending on how old or new the amp is. Oh, there's nothing, is there? No, that's the wrong one. That is a transistor. So we got dust and debris. This one, okay. It skips a couple little spots there because the strip is used in multiple amps. And we skip over So we're just going to add fresh solder. And that mixes with the old solder. It's going to help make it easier to remove. And trying to get enough on there where you can kind of solder a bridge across is actually a good idea. The only time a solder bridge is good. But we're going to get the solder sucker. And let me get this heated up real good. Get a good suction of solder. And I'm going to check one other here. And so what I'm going to do is get my magnifier out, and let me see if I can grab the used fit. So what we're looking for, I'm going to show you on this fit, is that sometimes when they're installed up in the board and the factory needs to trim the leads because the leads stick up through the board far, their cutters will leave burrs on the ends of the legs, and that actually makes the leg, because of the extra burr, makes it bigger than the hole the leg originally went through. And so if you desolder these and pull them through with that big burr on there, it can tear up the little vias that connect the top and the bottom side of the board. So everywhere there's a hole here on these boards, you see all these little bitty holes. There's a little copper via that goes from this side of the board to the other side of the board, and that's how the traces go back and forth to make all the circuits. So I sucked solder off of a couple of those. Now these are trimmed pretty short, but I'm going to use my magnifier and I'm going to inspect them. Make sure there's no big burrs on them. And there is not on these, so I feel pretty good about that. So I'm going to find, if I can find it somewhere. No. Oh, poop. Oh, there it is, right in front of me. My little spudger, my little fiber spudger pick. And I'm going to actually stick it up in there. And where we're putting it, I'm going to put it up underneath these legs. This is non-metal, but it's a high temperature kind of fiber reinforced plastic. And that way what I'm hoping to do is I'm wanting to pull these legs out when I heat it from the back side with my big soldering iron. And hopefully, let's go ahead and get the spudger in there. Just slide those through, since they're not gonna, it's not gonna come off very easy. Keeping them all liquid. Let's see how we did, if we got it up. Did not get it all the way out though, did we? That is a shame. Well, I am not willing to damage the board. Some of these, when they got a fewer on them, they can be done. Sometimes you can do it one leg at a time. We might try one leg here. Get a little solder on there. See, can you guys see that? Yeah, you can kind of see that. Yeah, there we go. That did it. Not sure if that's all the way out or not. That one's definitely all the way out. That one's definitely all the way out. I don't like using the metal so much because it robs the heat, but we got it, so that'll work. I'll just put a little heat through the top here. I've had some of these go different ways. It just depends. They use these strips on several different year models, and they still actually use them in some of the newer ones, a form of them. So it's not like it's not a good skill to learn if you have to work on them. Some of the new ones still use the MEHSA strip, or newer, I say. I don't know if the brand newest ones do. So it's probably helpful. Well, let's just give it a try here, because I had those others kind of lifted up. There's one. Looks pretty good. It just slid right up, because they're real short. They were cut off on the board real short, so that's kind of what's making this possible. A little bit longer leg, and may not have been able to do this. Definitely do not want to pull a via, so I'm getting plenty of heat in there and watching. You guys can't see it, but I'm watching for the solder to liquefy kind of down through where the hole is going. So that's actually working pretty dang good. Let me get a little more solder on some of these. Okay, got some solder underneath them. You can always clean up the solder with braid and solder sucker and everything. So don't be afraid to use a little solder to make sure you get good heat transfer. And get these legs right on out. This middle one's always going to be the hardest, because remember, it's connected to the back, and that's on that big old MEHSA strip. I think I need to raise this one up just a little more. There we go. Let's see. Come on, baby. Not liquidy enough yet. I think I'm solder bridged and losing a lot of my heat to the middle there. I think. Let's make sure that middle leg is up and out of the way. There we go. That's part of it. It's losing a bunch of heat to the middle leg. That's good. I kind of need to find my glasses here. Help me out a little. Alright. That helped me out a lot, actually. It's a whole lot easier to see that solder melt. Tons. So if I was doing this for a living, I wouldn't even have bothered. I was kind of trying to see if I could save maybe one or two of these. Maybe one or two wasn't bad, because I actually only have new of these spets. I don't have any to use for testing for blowing up. So like I said, sometimes you can salvage them. I know this one's dead and that one's dead, and probably that one's dead, so it may have been a big waste. But sometimes it's good to practice too. So now that we've got the legs free, we're going to take, I'm going to slide my chair out here. We're going to clean up our area from any solder debris and junk. I'm going to try to move. So I'm going to bring this out to the edge of my table. I've got my silicone mat to protect it. I'm going to use hot air gun, and it's probably going to make some noise. And a big soldering iron. I'm going to take the big soldering iron. We're going to get a little solder on it for heat conductivity. And it's going to go on the back here, back fit, and this hot air is going to go, oh, you can't see that, hang on. All right, a little more there, okay. Let me go back up just a little. So the hot air is going to work at the bottom of this thing, and I'm going to gently heat it back and forth for a little bit, because I don't want to burn it and I don't want to warp it. We ain't here to tear stuff up. So it's gentle, gentle. And this is a hot air rework gun that's used for soldering surface mount components and chips on and off. And then we're going to have our soldering iron. And we're going to lay the soldering iron on the back and just continue to heat generally around there. And I can see a little bubbling from the old flux, so that means we're getting close. There it goes, and I'm just going to flick it gently out of the way. We're going to go right to the next one, kind of get these warmed up. Now remember, these suckers will come off here burning hot. You flick them onto your leg or into your pants, you're going to wish you hadn't, and that's why I'm standing up, so I can kind of just sidestep out of the way. It is now officially spring, so I'm actually in shorts, and oh my gosh, it's wonderful to have a little spring weather. I'm so tired of winter, and I'm really, really ready to just be able to put my big box fan up to blow across and keep me cool and to keep all the solder fumes away from me. So here we go. This one's liquid. And when you get them close together like this, as long as you've been preheating down the board a little bit, starting to come free, almost there. You don't want to force it. You want it to get real nice and liquidy. Because if you force it, it's going to tear up the copper pad underneath. Uh-oh, we got a little something holding on. There we go. Right, we're going to reheat that a little. There we go, and boop, falls off. So this is all I do. I use one soldering iron on top to get it hot, my hot air underneath, and just try to not put too much heat to the board. I have cut them all off, all the legs off before. When I had a whole bunch of them that were blown, I've had little smaller ones that were all messed up. But that'll get it. And now I'm going to let that cool for a little bit, just so we get some of the heat out of there. We've already worked it, but then I'm going to clean it. And I'm actually going to rub my solder wick over all that and put some fresh, good solder on there. And when I do, let me grab all these. When I do, I will only put the tiniest thin little bit. So let's go back and get centered up here. Maybe right there. Is that good enough for now? A little cockeyed. Alright. So, flip these suckers over. Make sure none of the legs are touching. The hot air will shut off here in just a second. It runs through a cool down cycle when you put it back into its holster. So if there's some background noise, it will come off here in a second. Oh, and then we got my meter. So we're just going to put a diode check now that we took those 4 that were showing shorted. We're just going to check. Definitely shorted. Definitely shorted. Definitely shorted. Definitely shorted. So, blammo, dead. In the trash they go. Now, if you were doing this repair and you didn't kind of realize it before, we know what goes in what spot because it's identical. They were identical across the board. I checked that. If not, get you a little notebook. That's what I do. You can take pictures. You can do whatever you need to do to know which way those go in. But I'm going to, like I said, I'll show you a little cleaning. I'm going to do the cleaning up off camera. But but I'll put just this tiniest bit with my big soldering iron and then kind of go around and kind of get this all cleaned up. Because I'm wanting to mix that possible lead-free solder, depending on what year these were made. I have to do a little research on some of these old school amps. We may not have to worry about lead-free solder. I'm not sure. It was somewhere in the 90s when all that started. But then I'll get some of my solder braid and we'll go after it. And we'll get some of the excess solder just like that. We're kind of cleaning it as we go. And then it's still burning hot. That's why I said I'd do this off camera. By the time this really cools down, it'll look good. But bam, can you kind of see that that is so much better, so nice and clean. Yeah, there we go. And that, come on, focus. Let's try this. Let's try the little cam, because I really want you to be able to see this. So, yeah, there we go. We'll even turn around the right way. So see how that's basically all really nice and cleaned up. Where's my pointer? There's just a little bit of excess solder around the hole here. But whenever I put a little dab new fresh solder and smooth that all out, it'll be nice. But that'll freshen up all those places where we're going to do it. We're going to clean these, solder suck these holes out and make sure it's all clean, and I'll clean everything up. I will take the, where are they at? Here we go. Here's the 9540s. I'll take these and I'll pre-bend them into the hole and pre-line them up, and then I'll pull them back out. And I'll probably show doing maybe the last one, because it takes a while to heat it up and stuff. But we're not soldering them in the holes. We're soldering them to this back plane with them free floating in the holes. Then I'm actually going to take this unit, once they're all soldered here, set it back in the heat sink, put a couple of the screws in for the board and for this strip, and then going ahead and tack solder one leg of each, pull it back out, solder them all up right, trim the legs and everything. And the whole reason for that, and what makes these things tricky, and why I caution anybody that's not good at it, is that you can put uneven stresses on all your legs and get this thing all kind of warped and wobbly from the stresses of not having these all down. Then the thermal compound won't be, the whole back of this won't be against the heat sink very well. Your thermal compound won't get smashed out. It'll get uneven heating, and when somebody goes to rock and roll this, if you didn't do a nice proper job on these old Rockfords, you'll get a hot spot and you'll blow a channel, or you'll blow a power supply or something. So some people, I'm sure some techs would just go snip, snip, snip all of them, then solder on new ones with them pre-bent, clean out the holes and drop them in and be able to do it real fast, because they're doing it for a living. I've taken my time, everything like that. But extremely critical to make sure those FETs float in these holes on the board. Once they're soldered to here, we get it all clamped in the heat sink so that's flat and level, and we're not going to have this thing bent up or down. So it ends up being flat and smooth to the heat sink, so that after we do get all the solder connections and get it all right, it'll thermal paste up, it'll fit, smash in there, and this thing will last for a good long time. So wanted to talk about that. Like I said, sometimes when you get a really blown amp, it's just easier to snip them all. Take your time, don't overheat it. You'll end up tearing this thing up, but I'm going to go ahead and clean these up a little bit and then solder suck out these holes in preparation for making the next video. I'll get my FETs and everything out. I knew this one would take a minute, just because even though we didn't do a whole lot, it takes a while to get the heat to all this stuff. So it's a little boring. Like I said, that's what it looks like cleaned up. And actually, I could probably go ahead and add the smallest drop. Oh, excuse me. Oh, I'm gonna add the smallest drop. And we're just looking for a shiny surface. We're going to also coat the back of the FET with a tiny, tiny, tiny bit. And when you get the heat just right, they'll kind of just, and you'll see it kind of suck into place. So, okay, well, I hope this helps. Next video, we should see the FETs going in, or at least 3 of them in, and I'll probably put the other one in. Oh, no. I stand corrected. We still need to fix this RCA's where it's broke up here a little bit, and I want to go ahead and let's do a power up just like this with those 4 blown FETs out. We would not have been able to power it up. It would either protected or popped a fuse. So now we should be able to power it up and actually get sound out of these 2 channels over here. But nothing over here. But the power supply and stuff ought to be working. We can double check that we're getting rail voltage, and that we are getting our voltage on the op amps from the adjustable voltage regulators that I told you about, the LM337 and the LM317. And so we can check several things, and if all that seems good, it's kind of likely. The other thing we're going to do is I will, it looks like maybe here, several of these resistors, and we'll get a zoom in. I may even have to get my microscope over there. But these are the drive transistors, it looks like, and one of these resistors is going to be the gate resistor. They're kind of all done there. I'll do a little investigating so I can point that out and show where the traces are and stuff. I don't think there's anything on the back side. Nope, there is no components on the back side. So those should be the drive transistors that are driving a gate resistor to the FET. And so those are the 2 things we're going to check with the multimeter. Remember, I promised we would try to troubleshoot everything with the multimeter, and so we will do that. I just need to identify and look at them, and you don't want to see my fat bald head while I'm down here trying to do that, and maybe I'll make a little sketch out to the side. But we will get that done so that we can identify those, and we'll talk about them, show you how to test them. I'll see if I can get my either zoom in or something. As long as those test all good, we know that it was probably just the FETs that died. Normally, when your FETs die, you go back to the gate resistor first. And if it's still in tolerance and still all good, what the numbers read on it, and I'll read those numbers and talk about that. And then you go and make sure that the little driver, whether it's a driver like this or a driver like that, and these actually might be the drivers, but well, yeah, that one could be that one, that one could be that one. So like I said, we'll have to check. We'll test it, and as long as those don't test like they got shorted or blown open, as long as they test as a diode, because they are a semiconductor, then we can pretty much assume that just replacing those will fix it. But if we find one of those that are bad, once I look at the circuit board here real zoomed up and close and figure out which one's what, we will go back and repair that. Hopefully it only went back that far. We will then turn these gains all the way down, and I will show you on either the emitter resistor, emitter resistors setting the gain correctly, or via the current before we fire this side up. And you have to do that mounted up in the heatsink because you got bias transistors and thermal stuff that affect it and matter. So we will get to all of it, probably 2 videos more. One fixing this up and doing the test and testing all these points. The other one, I'll get all this soldered in, and then after we got that soldered in, we will show how to set the 2 ways to set the gains, and then we'll give it a final test, and we'll know it's repaired. So alrighty, thank you for watching. Subscribe, like, and then most importantly, love the comments. So leave a comment, leave a question. Tar amps final video, which is just a short quick video, but it's going to show the other Rockfords I've got, then kind of what everybody's picked. Just waiting a few more maybe people to comment on that tar amps number 3 video, I think it is, of which ones they'd like to see. But it's kind of looks like it's kind of definite. One of them I think we can do in about one video. It might be a little extra long. The others will probably take longer, but everybody's got a short attention span, so we'll break it up and put it in bites, and that way it's easy to reference too. If you've got a power supply issue, you know, 4 videos, one where we focus on the power supply, one where we do other stuff and everything. That makes it where you can focus on the video to watch for what your problem is. So, all right, I thank you for watching, and I will see you in the next video. Thanks a bunch.